Okay, this is it, the very last exercise in the 2-unit course, applications of the normal distribution. So the normal distribution, it's so real life. We talked about baby weights, we talked about heights, we talked about exam results, IQ scores, things like that. It comes up all the time. So it's very useful in terms of things like quality control and predicting outcomes. So here's an example. We've got a builder that requires 2 meters of floorboards for a building project. They buy floorboards with a mean length of 2 meters and a standard deviation of 2 millimeters. Any floorboard that is outside 3 standard deviations cannot be used. Okay, so 3 standard deviations would be 6 millimeters. If it's 6 millimeters too long or 6 millimeters too short, they're not going to be able to use it. Okay, so the first question is, what are the extreme allowable lengths? And that's what I just talked about, being 6 millimeters too long or too short. So 2 meters is 2,000 millimeters, okay, and it's plus or minus 3 standard deviations. Okay, so that'll give us a minimum of 1,994 millimeters, 6 millimeters too small, and it'll give us a maximum of 2,006 millimeters. Anything outside that can't be used. What percentage cannot be used? So this goes back to our empirical rule, okay? Remember, 3 standard deviations inside is 99.7%. So those that can't be used are the ones on the outside. So we're looking at these ones here and these ones here. So it's 1 minus 0.997, or you could go 100% minus 99.7%. And that's going to be 0.3% or 0.003, 0.3%, because they did ask what percentage. I did give it as a percentage. You could go 100 minus 99.7, as I said. What percentage are too long? So those are just the ones at the top end. Those are just these ones here, and that's going to be half of that previous answer. So 0.3% divided by 2, so 0.15% will be too long. Another 0.15% will be too short. Okay, this can also be used to do some comparisons. So if you've got a class that's at 2 tasks, and the results were normally distributed. So task 1 was normally distributed with a mean of 60 and a standard deviation of 17. Task 2 was normally distributed with a mean of 80% and a standard deviation of 5%. A student achieved 79% in task 1 and 83% in task 2. Which result was better compared to the rest of the class? Now, I can see straight away this 83% in task 2, that's less than 1 standard deviation away. Whereas this 79% is more than 1 standard deviation. Both scores are above the mean. This one's going to be the better one. But we do need to prove that. We do need to do the maths. And we do it by finding the z-scores. Okay, so for the 79%, it'll be 79% minus the mean divided by the standard deviation. Now, you can do those as decimals, or you can do them as percentages. I'm literally just doing 79 divided by 60 79 minus 60 divided by 17, and it's giving me 1.1176 as my z-score. And then for my task 2, it's my z-score is 83% minus 80% over 5%. Okay, that's going to make 3, so 3 over 5, so that's 0.6. So this one is a much smaller z-score. A bigger z-score is a better result, so this is a much better result compared to the rest of the class. Okay, so do that exercise and you are finished the course. Congratulations.